So you just built your amazing Web3 Solidity blockchain application, and then you tell your non-developer friends all they need to do to interact with it is to use the backend scripts or command line that you provide for them. Obviously, this isn't feasible. Now, after making our smart contracts, somebody needs to build a front end on top of these so that non-developers and the general can interact with our applications. And as a full stack developer in the Web3 space, one of the first things you're going to run into is how to connect your website or application to a Metamask wallet, or any of the other billion wallets that are out there. And in this video, we're going to give you the superpowers to show you exactly what's going on in the front end when working with Web3. Then we'll go through 6 different ways that you can connect your front ends to your smart contract applications, many of them using NextJS and React. And then at the end of this video, we'll reveal what you all voted for our 100,000 subscriber milestone. Let's get froggy. Now, please, 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 if you're watching this and you're following along and you're testing, please use a different MetaMask or a different browser wallet than the ones that you have actual money in it. What I like to do is I'll create a different profile in my browser, whether it's Chrome, Brave, Firefox, etc., with a totally different MetaMask. When developing, you should really only use a MetaMask specifically for developing. Don't use the same one that you have real money in with. Great. Awesome. All right, so here we are with a website or a front end on top of some smart contracts that we've deployed. Doesn't really matter what it is right now. This is typically the interface that you'll see, boiled down to a really, really minimalistic level. Typically, you'll see something like a connect function, right? And MetaMask or some other wallet connector thing will pop up. We'll hit next, we'll connect here. Might even say something like connected, and we can also execute functions. We can interact with our smart contracts, we can confirm, etc. Right? This is something you might see something like Aave, right? I'll hit connect on the Aave application. It'll say, hey, how would you like to connect? I'll choose MetaMask. I gotta change my MetaMask to mainnet, but you get the picture, right? This is a simple example of what that would look like. So what is actually going on in the browser when we connect? What is actually going on, and what do we actually need to do? We're gonna right click, hit inspect, and on the right side, we're going to see our debugger here. Now, if we go over to sources on the top of our browser, you'll see a few things. If you look down over here, right, we'll see this URL, right, which right now is going to be my localhost, and we'll also see MetaMask and Phantom and a whole bunch of other stuff. These other things that we see here are going to be what's injected from our browser extensions. The reason we see this MetaMask thing here is because I have MetaMask installed, right? The reason I see Phantom here is because I have the Phantom app installed. MetaMask, of course, being an EVM wallet and Phantom being a Solana-based wallet. Now, what happens when we have these extensions installed is they automatically get injected into a window object in JavaScript. And in fact, if we scroll down to here in the console, again, you can find console, you can click it here, you can click anything up there. And we type in window, we'll see we have this big window object with all this stuff, right? This window object represents our window, basically, right? Now, if we scroll all the way to the bottom and we do window.ethereum, we also see an object here. Now, this window.ethereum object only exists if you have a MetaMask or MetaMask-like browser. Or if you want to look at some other Web3 wallet, you do window.solana, right? And we see this window.solana. Now let's look at a browser that doesn't have MetaMask or Phantom installed. What do you think is going to happen in the window now? Let's go ahead, right click, hit inspect. We'll go to the console. Now let's see what's going on in here. If we go to sources, first off, we don't see that MetaMask or that Solana source here. And if we go to console, we still see window. Let me zoom in a little bit. We still see window here. But if I do window.ethereum, we get nothing. Or if I do window.solana, we also get nothing. So in order for our browsers to know that there's a MetaMask or that there's a Phantom, those extensions automatically add these to our window objects. And that's something that we can check for in our JavaScript. The reason these wallets are so important is built into them underneath the hood, they have a blockchain node connected to them. And in order to interact with the blockchain, we always need a node. And you might have seen URLs from Alchemy or Infura because you need them to interact with the blockchain. Alchemy and Infura are examples of third-party blockchains that you can interact with and basically rent, right? But you need them to create a provider or a node to send your transactions to. So you could do it in JavaScript, like something like this. This is the Alchemy documentation where you take that Alchemy URL, you stick it into some object and use that to send your transaction. This is a way that you could do it in the back end. But on the front end, what you normally want to use is you just want to use the user's MetaMask or their Solana or their wallet as the main wallet. Now, there are a ton of other different types of wallets to connect, like Ledger, Mu, Coinbase, Wallet Connect, etc. And there are different ways to set those up, but they all do the same thing where they expose some URL. They expose some node under the hood. They give us that URL. They give us that provider. The way MetaMask does it is with window.ethereum. Boom. This is now our URL. This is now our connection. In fact, if you go up to your MetaMask, hit the little three dots, expand view, hit add network, and then just hit the X so we can get to networks. You can see all of these blockchains that I have in here all have an RPC URL. This is the HTTP RPC URL connection of the blockchain node that's running. I happen to have one running locally right now. All of these also have a node RPC URL, and you can actually see them right in your MetaMask, right? This is connected to Infura. These are all connected to Infura. It's all the exact same thing. MetaMask just has a really nice way of taking that URL, sticking it in the browser for us in this window.ethereum or window.solana, or whatever. So this is the main thing that we need to know. We always need a connection with the blockchain, and these browser wallets are an easy way to do that. Make sense? Great. Let's take this knowledge now and let's apply it. All right, now I'm in my Visual Studio Code. You can go to any code editor that you want though. I do have a link in the description to setting up your VS Code if you've never worked with it before. So let's create a quick readme.md and we'll talk about what we're going to be going over. So first, we're going to go over doing everything in HTML/JavaScript. Everything in HTML/JavaScript. Now, because nobody builds a front end in just HTML and JavaScript anymore, we're going to work with some Next.js and React frameworks. Next.js is an incredibly powerful framework based on React, and I think it's a lot easier than just pure React. So that's why we're going to be working with it. Next.js is built on top of React though, so all your React knowledge still applies, but I promise you, you're going to like it a lot more. So then we're going to do Next.js, like I said, /React and raw Ethers. Ethers is one of the most popular JavaScript libraries for working with blockchain, for sending transactions, for executing functions, etc. Then after that, we're going to get more advanced and we're going to use some more advanced tooling for the Web3 space. We use Next.js and this package called Web3-React, then Next.js and a package called React Moralis, then Next.js and a package called Web3-Modal, and then Next.js and a package called useDapp. So we have a lot of stuff to do here. There's a lot of different ways to work with our front ends, and we're going to work with all of these. So let's get it. Now, everything that I'm going to be going over, I have a repository for it. And the link for this is in the description called Full Stack Web3 MetaMask Connectors. Each one of these links out to an individual GitHub project, right? With all the requirements, the quick start, everything you need to be successful if you want to follow along, if you want to copy paste the code. So all the code is going to be in my GitHub. Link in the description. So first up, HTML/JavaScript. So I'm just going to go ahead, create a new file and call it index.html. As most of us know, HTML is how websites are rendered. They're rendered using this HTML thing. So we're going to start creating a real basic HTML file here. If you type in ! in VS Code and just click that first thing, you'll get kind of some real basic stuff here. And we're just going to simplify this a bit by deleting those. We'll call this JavaScript test. And in our body, we'll just write hi. Now, if you want, I have an extension called Go Live that you can look up, called Live Server that you can run. And actually, if you hit Go Live, what'll happen is you'll start a live server,
write to your files, and we see hi right here. If you aren't using VS Code, that's totally okay. We have a solution for you too. You can install this package called HTTP server with npx or yarn. Again, links to install yarn and npm and all that stuff are in the description. But what you can do once you globally install it, you can install by doing yarn at HTTP server or npm install, whatever you want to use. And then you can run yarn or npx HTTP server, and it'll spin up a server for you and it'll do the exact same thing. So if you're using VS Code though, I highly recommend using this as it's a lot more friendly, but you can use that too. And now you'll see we've dumped a whole bunch of different stuff in here, like node modules, package.json, yarn.lock, but really we're just focusing on this index.html here. All right, great. Now to write some JavaScript in this HTML, we can just do a script tag like this. And now we can write JavaScript in here. So we could do like something like console.log, hi, and back on our front ends. Oh, let's go ahead and refresh. We'll inspect, go to the console, and we see hi printed out here, right? So we can do all of our JavaScript stuff in here. So what we want to do is we want to check to see if that window.ethereum exists, right? And if it does exist, we're going to send a request to it. So let's go ahead and do that. So we're going to do if, actually we're going to say type of, oh, let me turn GitHub Copilot off. Window.ethereum, Ethereum does not equal undefined. Then let's just say console.log. We see Metamask, right? So we're saying if type of window.ethereum isn't undefined, right? If this is defined, we're just going to do console.log, we see Metamask. And now we do refresh, and we do indeed, we see Metamask. Great. So now that we know that we can see Metamask, what do? Well, we want to send that request, right? If we look right now, we click on our Metamask, we are indeed not connected. Now, it used to be window.web3. It's recently been updated to window.ethereum. So you might see some older stuff to talk about window.web3. We're going to call this ETH request accounts. It used to be ethereum.enabled, so you might see that in some older stuff as well. So let's go back in here. What we can then do is we can do ethereum.request method eth request accounts. Oh, and it looks like it was a little ambitious over here too. So I'm going to go ahead and cancel it. But if we inspect this, right? Do a little refresh here. We can see Metamask is popping up because we're calling this method here. So immediately when this browser loads, we see if window.ethereum exists. Great. We're going to call ETH request accounts, and this is how we connect. Boom. That's simple. Now, we probably don't want it to pop up right away because anytime I disconnect, right? If I disconnect here, it'll very annoyingly re-ask me every time I refresh. So, and it'll throw a bunch of errors when I cancel. So what we're going to want to do is we're going to want to wrap this into a button, right? We're going to want to wrap that into a button. So instead of all this, maybe we're going to do button. We give it an ID of connect button. We'll say on click equals connect. And we'll call it the connect button. Right now there's no connect function, so I'll call it and it'll freak out. But we can see if you zoom in a bunch, we now have a button that says connect. Yay. What we can do is back in our script tag, we can do function connect, async function connect, and then we'll just pop this in here. Great. So now we have a connect function. Now if we go to our front end, we do a little refresh. It's not going to annoyingly ask us all the time. We hit connect and boom, it does indeed pop up. So I'm going to cancel them. Awesome. So now that's how we just connect to this. And that's it though, right? This is as simple, this is as small as it gets. You just slap this into your browser and boom, you now have a way to connect to the blockchain. However, this isn't everything, right? We want to also be able to execute. We want to be able to send transactions. So how do we do that? Well, we need to create another function. And this should actually be a wait, but you get the picture. So we need to create another async function called execute. A sync function execute. Now that we have a provider and we have some accounts to work with, we can actually start executing some functions. Now we could go ahead and rebuild the wheel and we could go and do everything raw and do everything ourselves, but we're engineers. We don't want to do that. So what we typically do is we'll use something like the Ethers.js package to help us send these transactions. You can use Ethers.js. You might have also seen Web3.js. These are both JavaScript packages that have all this functionality for sending transactions. So we're going to want to use that instead. Now, because we're going to want to use a package, we need to first install it. So I'm going to do yarn add ethers. So we've gone ahead and installed ethers here. And we can't actually import packages right in the browser. So we're going to go ahead and create a new file called index.js. And we're going to write all of our regular JavaScript in here. We're going to turn it into browser compatible JavaScript. And that's what we're going to use in the index. So if that's confusing, don't worry, just bear with me. Hopefully it'll make sense in a minute. So we're going to delete all this stuff that you see in script. And over in our index.js, we're going to paste that back in here. So we have our connect function. We have an execute function. The first thing we're going to want to do at the bottom is we're going to do module.exports equals connect and export, or excuse me, execute. Execute. So we're exporting these functions so that when we do browserify our JavaScript here, it'll work for the front end. And great, so this is going to be our connecting function. Let's create some execution function. So first, we're going to grab that ethers package. So we're going to say const ethers equals require ethers. And that's how we get ethers in here. Now that we have ethers, we can go ahead and execute some function. Now, whenever you execute a function, I say this a million times, there's a couple things you need. You need an address, you need the contract ABI, or basically the blueprint to interact with a contract. You need the function, of course, and then you need a node connection. We have a node connection. That's going to be our Metamask. We don't have a function, we don't have an address, and we don't have a contract ABI yet. So let's go ahead and make one. So I have another package on my GitHub called Hardhat Simple Storage that will deploy a really minimalistic contract called Simple Storage that looks just like this with some minimalistic functions. And it comes with Hardhat, which is a local fake blockchain that we can use. And this way we can test out doing transactions and executions without actually having to do it on a testnet or on a mainnet. You can also use Ganache if you're familiar with that. But basically, we just want to get some smart contract and some blockchain so that we can do stuff. So in a second terminal, and we're going to have two terminals here, we'll do git clone that package there. We're going to cd into Hardhat Simple Storage. And first, we're going to hit yarn to install the dependencies, and you'll see what we're doing in just a second. Once we have all the dependencies installed, we can go ahead and run yarn hardhat node. And this is going to do a couple of things. If we scroll up on this, first, it's going to deploy that simple storage contract that we just saw at this address on a fake blockchain that we just spun up. So first, it's going to spin up a fake blockchain running in this terminal, in this little terminal here, deployed simple storage at this address here, and it's going to give us a whole bunch of fake accounts. Next, what you're going to want to do is you're going to want to grab this endpoint here, start HTTP WebSocket JSON RPC server here. This is now our blockchain node. So we'll go to our front end. We'll go to our Metamask and we'll hit add network and we'll add the network name. I'll call it hard hat localhost. You'll paste that in. You get the channel ID of 31337, currency symbol ETH, and no block explorer, and hit save. I already have mine added, which is why I get this error here. But once you do add it, you'll get a new network called hard hat localhost. Next, what you'll do, you'll come to your accounts, you'll hit import accounts, stay it on private key, and you'll grab one of these private keys that MetaMask automatically gives to you. I've already done it, which is why you see my account 8 here with seemingly infinite Ethereum, but it's not actually infinite, you know, it's fake money. So what we want to do now is we want to grab this address, right? Because we're going to need an address. So great, we have that address now. So we'll say const contract address equals, boom. And we'll close this for now. Great, and now we have an address. We'll need an ABI. We can actually find the ABI if we go into our hard hat simple storage folder, go to deployments, simple storage, .json, and we just grab this ABI bit here. So we can literally go like this, copy the whole thing, and paste it and say const ABI equals this bad Larry. And we'll delete that. Boom. Const ABI is this whole big thing. This is the blueprint to interact with the contract, and you need this to call functions. Great. We have the ABI. And finally, we need the function that we want to call. So if we look at our simple storage contract quickly, there's one function that anybody can call called store, and we just pass it a favorite number, right? We pass it a favorite number. So this is what we're going to call. This is the function that we're going to call. So we also have a function. Yay. Address, contract ABI function, and a node connection. Okay, cool. So here's the contract address. Here's the ABI. All the way down here. I know it's a very long ABI. Now what do we do? Well, this is where we stick our MetaMask into Ether. This is where we stick our provider. We stick that MetaMask into Ethers. So we can say const provider equals new ethers.providers.web3 provider. And the provider is going to be window.ethereum, right? Remember how I talked about how this MetaMask is going to be our provider? We're using this as like our RPC URL, right? We could also just as easily stick something like this in, right? But we want to connect to the user's MetaMask, right? We want to connect to whatever network they're working with and whatever network they are on. We don't always want to force them to our local blockchain. So great. So we have a provider. Now we need a signer. What's a signer? Well, anytime somebody executes a transaction, somebody needs to sign it. Somebody needs to execute it. Somebody needs to be like, hey, I'm the one who executed it. And we can get that from our MetaMask. We can get that from our provider. So we just do provider.getSigner. And this is going to get the connected account into our ethers here. So great. We have a provider. We have a signer. Now we put those all together into what's called a contract in ethers. So we'll say const contract. This is that simple storage contract we're going to do equals new ethers.contract. And we pass it the contract address, the ABI, and the signer. What this means is we're saying we're going to be interacting with this contract address using this ABI, and any function called is going to be called by the signer, right? So it's whoever connects here is going to be the signer. So whoever's connected is going to be the one who's going to call these transactions. Next, we're going to do await contract.store 42. So this is where we call that store function on our simple storage.sol contract. And then that's it, right? And what we should see when we call store, we should see in our terminal with our hard hat blockchain running, we should see a transaction come through, right? Once we call that execute function. So this is the real minimalistic way to go about and do this. Now, if you go to my GitHub, you'll see the code is a little bit different, right? I've added some quality of life stuff, like some try catches and some document.get element by and changing the text once we click buttons and stuff, but it's going to be basically the same, right? So you will probably want to do some try catches when you're doing these in prod though. But at the same time, you're not going to be doing HTML, JavaScript like this in prod. You're going to be using, NextJS or something. Anyways, now that we have our JavaScript basically done, what do we do now? Well, we're going to need to add it to our index.html. So what we can do is we can do script source equals index.js. And then we can also do text equals, type equals text/JavaScript. And then additionally, we're going to add a execute button. And this one's going to call our execute function. And we'll say execute. Great. Now you notice something. We're able to connect fine, right? We'll go ahead and connect. Great. But if we try to execute, we'll get cannot access ethers before initialization, right? And it even gives us like where. It's like, what are you talking about? What is this ethers thing? And again, this is because this require stuff doesn't work in the browser. So we need to browserify our JavaScript. We need to take this JavaScript that we wrote, and we need to transpile it into a way that the front end can actually understand. So we're going to add another package to help us do that. This thing called browserify to do exactly this. And so we can install it like this, or we can just do yarn add browserify like that. And now we can transpile our index.js into browserified index.js. So what we'll do is we'll run yarn browserify index.js -- stand alone. And we'll call it bundle. And we'll set the output file to ./dist/bundle.js. So now we have a dist folder, which usually stands for like distribution, and we have this bundle.js. Now that we've created our standalone, we've created our bundle.js. Back in our index file, we'll change this to dist/bundle.js. And then we'll do bundle.connect and bundle.execute. So our JavaScript, our HTML will look just like this. Now, if we go back to the front end, do a little refresh, make this look a little nicer. And you'll notice if you're already connected, right now we didn't do any fancy stuff to make it say connected, so it just won't do anything. But once we're connected, we can verify by looking right here. We'll go ahead and hit execute, and we'll see Metamask pop up again. Remember, we'll need to be on the account that has the money in it. And we'll go ahead and hit confirm. If you get this error here, it's because of all the finagling that we're doing. Just come up to your Metamask, hit your account, make sure you're on the account with all the fake ETH in it. Go to settings, go to advanced, scroll down to reset account, reset. Great. Now, go ahead and refresh, make sure we're connected. We'll hit execute now, confirm, and we won't see any errors. But if we go back to our terminal and we go back to where our hard hat node is running, we'll see a new transaction has gone through. ETH send raw transaction, contract call, and this is all the stuff that it's doing. And if we go back to our MetaMask,
we'll be able to see that transaction have gone through. Obviously, there's not going to be a block explorer because it's a local blockchain, but that's really it. And that is the most minimalistic way to connect your front ends to your smart contracts. All right, we've got our first one done. Yay! And remember, all of these have a GitHub repo. So if you get confused, if you get lost, come over to GitHub repo. If something doesn't work, make an issue, etc. And if you're having issues getting blocked or really with anything, be sure to watch my Defeat Any Coding Bug video. It's going to help you debug literally anything and get help the fastest. But anyways, now that we've got this first one done, let's go ahead and move on to our next one. Why? Well, because nobody's actually going to use just HTML to build their applications. They're going to do something like NextJS, React, Angular, Svelte, etc. We're going to be doing NextJS for all of the following demos, but we're going to show a number of different ways we can go ahead and approach this, each with their own trade-offs, and we're going to explain the trade-offs, of course. So the first one we're going to do is we're just going to do a raw Ethers NextJS application. And again, all of this is on my GitHub. Links are in the description. Let's come to our VS Code. Go ahead and we'll close everything out. We're going to create a new file called NextJS Ethers, cd into NextJS Ethers. And we're going to open this up into a different VS Code window here. Of course, you can also hit File, Open, which will pull the drop down and open up the file like so. Great. And the way we're going to get started is we're going to make a basic NextJS application. And the way we do that is with yarn, create next app, put a little period here saying we want to be in this directory. And with this, we'll have a very basic NextJS project here. In fact, if we just run yarn dev right now, we'll get this, which pops up into this welcome to NextJS application that's running right from our VS Code. So let's go ahead and smart contract Web3ify this. So if we go into our pages, let's go to index.js. Yeah. Now let me give you a quick walkthrough of what's going on with Next.js, okay? So this .next has a whole bunch of framework stuff, and we basically always ignore this. Node modules is going to, of course, be all of our dependencies. Pages is really cool. Any page you make in here, any file you make in here is going to be a new page. This app.js is kind of the entry point for everything, and the index point is going to be the home page, right? So all of these pages basically route through this app.js. So just ignore this one as well. And index is our home page. Public is just going to be like some public images and stuff. Styles is going to be some styles. This is like your CSS. This is how to format stuff, make stuff nice. This is a linter. We're going to ignore this. This is for GitHub stuff. This is, we're going to ignore this for today, but this is a next config. This is your basic packet.json for packages and dependencies, README, and yarn.log for dependencies as well. We are going to focus solely on pages. We're not going to go anywhere else. We're just going to stay right inside here. We're even going to delete car.js. We'll go to index.js, and we're going to delete everything below this first div. We're going to go all the way down to the last div, save it, and then we're just going to put hello Patrick or hello frogs. Of course, I can't find car now, but now we see hello frogs. We'll even zoom in a lot. Hello frogs. Cool. So let's go ahead and front endify this, right? So first we're going to need to connect to Metamask, and then we're going to need to execute a function. Great. So let's create a little function. So we'll do async function connect in here. We're working with Next.js. We have to do this if type of window.ethereum does not equal undefined in the component bit. Because Next.js has done some stuff to make it so that window doesn't exist, right? Next.js doesn't know about window, but that's fine. There are some ways that we can actually get around it. And one of those is going to be putting it into the component. And again, we're going to say if type of window.ethereum, Ethereum does not equal undefined
Then we're going to go ahead and try. I'm going to do a try catch here. We're going to run await ethereum.request. And this is where we pass this method in again, right? Request ETH accounts. And this time we want our button to only exist if we're not connected, right? We want it to say something different. So I'm going to add in here something called a useState. So we're going to say const is connected, set is connected equals useState, false. And we're going to import this. We're going to do import useState from React. And I know it's failing down here because we need to do catch e console.log e. So in a try catch, we need to have the catch part. So anyways, what this useState is going to do, it's going to give us this is connected variable and this setter, set is connected. And you might be thinking, okay, well, why don't we just do let is connected, equals false. What's the difference between doing this and doing this weird useState thing? Well, the difference is that useState helps us keep state between renders. So we're not going to go too deep into front end stuff here, but that's basically why. So we're going to use this is connected, set is connected. And so once we connect here, we're going to do set is connected to true. And then we're also going to use this connection to get a provider. So we're going to do const provider, set provider equals useState. And we'll just leave it blank. And we have set is connected. And now we're going to say let connected provider equals new ethers.providers.web3provider of window.ethereum. And then we're going to do set signer to connected provider dot get signer. And I think it even popped ethers in for us right here, which is great. We're actually going to kill this yarn add ethers just to make sure we have it. React gets installed by default with NextJS, so we don't have to install that there. Great, let's start it back up with yarn dev. And cool. And then we'll just do if type of window.ethereum, is undefined. We're just going to do else set is connected to false. Cool. Let's go to our front end. We'll do a little refresh. Nothing happened here. Why? Because we need to create our button that's going to call this connect function. So let's wrap this parentheses. And in here, we'll do a button. We'll say on click equals. This is where the syntax is going to be a little bit different. We're going to say on click equals a function. And that function is going to be connect. And this button is going to say, oops, don't need that there. And this button is going to say connect. Great. We hit refresh. We have this connect button now. Are we currently connected? We are. Let's disconnect. Now let's connect. Metamask pops up. Perfect. Now, something that you'll typically want to do is you'll want to do something like, you'll only want to show this button if you're connected. So maybe you'll do something like is, we'll put some JavaScript in here, is connected. And if yes, so this is called a tertiary operator. It's the same as doing like if is connected, do this, otherwise do something else, but it's just kind of nicer for this JSX stuff. So we're saying if is connected, let's do something. If not, we'll do something else. So if we are connected, we'll just have this say connected. And if we're not connected, we'll copy this whole thing, stick it right here, save. We'll do, and again, mine auto formats. That's why it keeps doing that. So if we're not connected, we'll show our connect button. We'll go back over here. And now when we hit connect, it says, hello frogs, connected. Great. So if we refresh, we'd have to save the state, but you get the picture. Cool. Showing that we're connected. Awesome. So we have our connect button. Let's now create our execute button. So do async function execute. This is going to be really similar to what we did before. And in fact, we can just copy paste it in here, right? So I just copy pasted it with some additions. Type of window.ethereum is undefined. We have a contract address. We have our massive ABI. We removed the part about the providers and the signers because now our signer is up here and we got to change this to set signer instead of set provider. Sorry. Get signer. Okay, great. And then we have a try catch for await.contract.store42. And console.log error. So, and we could add some more stuff here to make it, the way that I have it currently set up in here in my GitHub, I have it a little bit fancier. If we scroll down to my GitHub where it says, please install Metamask. If you don't have Metamask, it doesn't show the execute button unless you're connected. Actually, no, yeah, let's go ahead and add that in too. But we're going to make ours a little bit easier. So we have this is connected bit. And if we're connected, we're going to add another button. Oops, excuse me. If we're connected, we're going to say connected. We're also going to add another button where we call on click. We're going to call a function execute. And we're going to call this execute. But we got to have this be in a little React fragment. Boom. So this is called the React fragment here. We have a little button here. Awesome. Go back to our front end. Connect. We see we're connected. We can call execute. Of course, we're going to get an error because right now our hard hat instance isn't running. I'm going to go ahead right now, since I have a transaction here, I'm going to go ahead and just reset this account because it's hard hat's going to get confused. Advanced reset account. Yes, that's fine. So again, we're going to pop open a new terminal. We're going to go back to that hard hat simple storage. And again, we're going to run yarn hard hat node. This is going to start up our local blockchain. And again, we have all the private keys. Simple storage has been deployed to the same contract address. The ABI is going to be the same. Great. So let's scroll at the bottom. Now, if we refresh, we'll do connect, we'll do execute. Contract address is not defined. So let's fix that. Oh, I should do const contract address. Now let's try it. Connect, execute. Got a different error, console. Metamask is having trouble connecting to the network. Let's just disconnect and reconnect. So we'll do a refresh, connect, scroll down to the account, connect. Great, looks like we're connected. Now we'll hit execute, MetaMask pops up, and confirm. If we scroll down, we see that transaction has indeed gone through. And again, since we're doing more basic stuff here, you'll run into a whole bunch of issues like I just ran into, right? Which is good. You'll get to learn more about what working with these local chains looks like and what it's about, right? So the issues that I ran into right there was that my MetaMask was connected to the local blockchain, and then I stopped the blockchain, and then I restarted it, and then I restopped it, and so I got a little confused, right? And so you'll probably run into the same things. And you'll get really good at working with it. All right, boom. Two down. All right, let's go. That's how we can connect and send transactions with just Ethers and just NextJS. Now, what you're going to run into, though, is that as you switch pages, right, as you switch around, this state
that you created, like is connected, the signer and stuff, you're going to probably want this signer in other pages. But there's got to be an easier way, right? We don't want to have to do all this work, right? We had to do a lot of work. We had to code a lot. We had to do a lot of stuff. There's got to be an easier way to do this stuff than what we're doing right here. And there's a ton of packages to make our lives a lot easier. And one of the ones the first one we're going to be talking about is Web3-React. Now, this is one of the big players. This is being used by protocols like Uniswap. And you can even see if we go to the Uniswap GitHub, we go to interface, they're using Web3-React. app.aave.com. They're using this Web3-React as well. So this is like a really, really powerful framework that we're going to be using. So let's go ahead and do this. So we'll CD down one. We'll leave this running. We'll leave our hard hat node running because we're going to still be using it for futures. And that way we don't have to reset our account. But let's create a new directory called NextJS Web3-React. We'll CD into NextJS Web3-React. And we'll open up a new folder with just this one. You just move this over to the side, really, and just have it running in the side. Or you could start it up in your own new terminal again. You know, whatever you want to do here. It's what you want to do. But okay, so we're in a new folder and we're going to be doing the exact same thing. And let's do this. So same thing, go to index. We're going to delete everything between the divs here. And we're going to add this Web3-React package. So we're going to do yarn add at Web3-React/core. We're going to do yarn add ethers as well. This Web3-React, it also comes with this thing called context, which is really, really powerful. And if you go to their documentation, again, link in the description, or Web3-React provider, these are ways to wrap all of your code in this provider. That way, all your apps know about the state of the providers and if you're connected to Metamask and etc. And actually, all of the applications we're going to work with have this wrapper so that all the applications know about, you know, Metamask and stuff. So we're going to remove everything in here. And if we want, we can even do yarn dev. Maybe we'll say hi frogs in here. Go to our front end. Oops. Localhost 3000. And we'll see hi frogs. Cool. So now what we're going to want to do is we're going to want to wrap this component in this Web3-React provider. And again, this is going to add context and it's going to help make it easier for our application to remember the state of whether or not we're connected to MetaMask between each page, right? So the way we're going to do this, we're going to do import Web3-React provider from at Web3-React core. And we're also going to import Web3 provider from at Ethers project/providers. So we're going to have to add this as well. So we'll do yarn add at Ethers project/provider. And this is just a minimalist version of Ethers, right? So this is a way to get just the providers into here without all of Ethers being imported. And you'll see why in a second. The reason we need it is because this Web3 provider needs this get library function. It needs a get library function in order to exist, right? So we can just go ahead and create const get library. And this is going to be a function that takes a provider as a parameter. And this is some syntactic sugar. It's the same as saying, you know, function get library. You know, it's basically the same as doing this. But JavaScript has a bunch of crazy different things to do. And all we're going to do is say return new Web3 provider. And this is how you can actually define how to get different providers with this Web3-React. Since we're just keeping it real simple, this is how we're going to do it.
So it has a field called library. We're renaming it to provider, and it has an active thing so we can check to see if we're actively connected or not, which is really helpful, right? And we can use this hook across all of our different pages to always know if we're connected or not, right? And that's what the value of wrapping it like this does. If we didn't wrap it like this, we would have to reconnect on every single page, which would obviously be awful. This way we connect once and we're good to go. So let's add those functions again, right? Now, when we do our async function connect, instead of doing it with window.ethereum or whatever, what we can do is we can just say try await activate with some provider, and then, you know, catch e console.log e. So activate is another one that we're going to grab from this Web3-React. It comes with this this wonderful activate function, and we have to tell it what we want it to activate. So Web3-React comes with a whole bunch of built-in connectors. So Metamask is one of the main ones. However, there's a whole lot more. And if you go to connectors, you can see there's one for Ethereum, Fortmatic, Frame, Injecting. This is going to be like your Metamask, Ledger, Magic, Network, Portis. There are all these different type of wallets that have different kinds of connection pieces, right? If you want your application to support all these, all you have to do is import them and support them. So we're going to work just with the injected, but if you wanted to work with more, you would just import more. And when await activate, you would just choose whichever one like the user pressed. So we're just going to do import injected connector from at web3 react / injected connector. And then what we're going to do is in here, we're just going to say const injected equals new injected connector. So now that we have injected, this is what we're going to want to use. We're going to say, hey, we want to use the injected provider. We're going to connect to the injected provider, but if we wanted to connect to someone else, we could easily just read the docs for somebody else. So I'm going to kind of speed through this part down here because we've done this a couple times now. Great, we have our connected button and we have an execute button. So if we scroll down, so I kind of sped through this, but now we're just using this active thing, which comes from this use Web3 connect. And we have we're saying if we're active, show connected and show the execute button. If we're not connected, show the connect button. Great. So now we just need to do async function execute. So now we're just going to say if active. What are we going to do? Say const signer equals what? We can get the signer right from this provider variable now. So we can just say provider dot get signer, which is really helpful. We'll say const contract address. This is going to be the same. And typically what I like to do actually is I'll add that ABI to a different folder called constants so that it doesn't muddy stuff up. So you just do module.exports equals ABI, this big thing like this. And then we can just do import ABI from constants / ABI, like that. Now we have the ABI, and we can once again do some wonderful Ethers stuff here. Const contract equals blah, 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 the whole 9 yards, same thing we've done before. And boom, we now do connect, execute. Oh, did I not import? Oh. Ethers. We'll import Ethers, do a refresh, connect, connected, execute, bada bing, a bada boom, confirm. All right, cool. 2 down. What's next? Now, what if we wanted even more functionality? So doing all this stuff with blockchains is really important because of decentrality, et cetera, et cetera. But you'll notice a lot of applications like OpenSea, like Etherscan still have some centralized component, right? I can go to an NFT, I can like that NFT, Metamask will pop up, but it's just to sign something, right? It's not to actually send a transaction. Well, what's up with that? That signature actually gets stored in the OpenSea centralized database but authenticated with my Metamask. And these functionalities are incredibly important and can make these applications really feature rich, but they don't require making and sending a transaction. And that's what we want. So we're going to need eventually to have some type of Firebase for crypto, some type of centralized database to make even more feature richness. And this is where Moralis actually comes into play. So Moralis has a React package as well that has all these hooks, that has all these functionality. It has this context provider, and additionally has the option for us to opt into having a server that runs all of our applications as well, if we want it. So that's what we're going to do right here. There's going to be a bunch of stuff we know we're going to need. So we're going to add our constant/ABI thing in here again. We're going to go to pages. We're going to do the same thing. We're going to delete everything in here. Goodbye. All right, cool. Now what? Now there's an incredible site called Ethereum Boilerplate, which has this repo with a ton of this stuff already built in that you can go check out. And I definitely recommend you checking it out and deconstructing what's in here to build for your own application. But the way we're going to go ahead and install this, we're going to do yarn add Moralis and React Moralis. So we're going to do import Moralis provider from React Moralis. Then in here, we're going to do Moralis provider. And here's where some of the amazingness that this platform comes into play. Since it's an open source application, they have a whole bunch of docs and everything. We can also just go right to the GitHub. It has this initialize function. So if we want to, we can connect it to a server that's connected right with Moralis. So we don't have to worry about hosting, databases, all this stuff is built in with Moralis and it's really powerful. Or we can just say, hey, we don't really want to work with your server, but your React hooks are dope. So we'll take those. And that's what we're going to do. But having the functionality to go ahead and turn a server on later makes it really, really easy to, when you reach that point, say, hey, I'm ready to deploy. I'm ready to add all this amazing functionality. I'm ready to host this on a server. It's really easy just to flip your provider to being this. So we're going to go ahead and grab this. And we're going to say, Moralis provider initialize on mount is false. So this is basically saying, hey, we don't want a server. But again, we could do that later if we wanted to. And then we're going to close that provider. We'll say return this whole thing. Boom. Cool. And then we'll go to index.js. We'll say hi again. And we'll do yarn dev. We have hi and we have a little semicolon in here because we added a little extra semicolon in here. Whoops. And right now it has this warning bug. You can just ignore this for now, or you can yarn add magic SDK and yarn add at wallet.connect/Web3 provider to get rid of that if you want. Now in our index, similar to Web3-React, we have some hooks we can use with Moralis. So we'll do import use Moralis, comma, use Web3 contract from React Moralis. And we can do const enable Web3 is Web3 enabled equals use Moralis. And I bet you know where this is going. Now I'm just going to copy the button setup from the Web3-React because we've done it a couple times, but instead of active, we can just use this is Web3 enabled. And now for our connect, we don't even need to write a connect function. We can just do enable Web3. Boom. Let's pop into our front end, do a little refresh. Make sure we'll go ahead and disconnect here. our hard hat local blockchain is indeed running. We'll go ahead and hit connect, and boom, we didn't even have to write a connect function with the Moralis hooks. Now execute isn't going to do anything, of course, because we haven't defined our execute function. So let's go ahead and do that. So Moralis also has some hooks for executing smart contract functions. And it's with the hook called use Web3 contract, which I've already included in here, use Web3 contract. So we can do const run contract function, and there's a whole bunch of other stuff that comes with it, like is fetching, is loading, data error, etc. But we can say run contract function equals use Web3 contract, and we'll just put the parameters in here of what we want to do. So we'll do ABI, which will be ABI. We'll go ahead and again import that. So we'll do import ABI from /constant/ABI. So we'll say ABI is ABI. Contract address is going to be, again, that same contract address or whatever contract address you're using. Function name is going to be store. And the params. So our params were favorite number, and we're storing 42. And that's it. Now we don't even need to create an execute function. We can just do connected on click, run contract function. And if we flip back to the front, go ahead and do a little refresh, connect, execute, and boom. Even easier, easily the easiest way that we've done so far to go ahead and connect and get set up here. Now, this is a setup I'm going to highly recommend people look into it and look into using, because it just makes life so much easier. I've used Moralis for a number of projects. It's absolutely fantastic. Now, moving on, what's next? Well, we could look into Ethereum boilerplate and kind of same as the Web3-React, it has all these plugins for different injectors, right? Which is cool. Wouldn't it be great if those plugins, those injectors kind of just came out of the box? And that's what Web3Modal is. So guess what? We're doing it again. CD down, make dir, NextJS Web3Modal. Now, this is used by this project Scaffold ETH, which is created by Austin Griffith, who you should absolutely know about in this space because he is absolutely phenomenal. This is another thing along with Ethereum boilerplate to reverse engineer and figure out how to do your React stuff, right? If you come in here, if you come to the source components, it's a wonderful, wonderful application for both learning about front ends and Web3 and all this stuff, but also reverse engineering for your project. So Ethereum boilerplate, Scaffold ETH, two projects you absolutely, absolutely want to pay attention to. And Scaffold ETH uses this thing called Web3Modal. So we're going to do yarn create next app. You know the drill. I'm going to paste those constants in here. And great, we're going to fly through this one even faster. We're going to go to pages, index, delete everything. Great. Now the package that we're going to add is Web3Modal. And this is a package that once you hit connect, it'll automatically prompt you with these buttons instead of you having to actually code these buttons in yourself. So what we can do is we can do import Web3Modal from Web3Modal. We'll do let Web3Modal. And this Web3Modal, what it needs is a list of the providers that you want to give it. And it comes default with Metamask. So we don't need to tell it about Metamask, but we do need to say const provider options equals some list of provider options. So we need to tell it what provider options that we want to do. Now, Wallet Connect is easily one of the most popular ones. So we'll say, all right, cool. We want you to support Wallet Connect. So how do you support Wallet Connect? Well, we got to give it the package, which is going to be this Wallet Connect provider that we need to add. So we'll do yarn add at Wallet Connect /Web3 provider. And then once we install that, we can do import Wallet Connect provider from at Wallet Connect web3-provider. Package wallet connect provider. And then we'll do options. And this is all, you can see this all in the Web3Modal documentation. We'll give it an RPC option. And then we put in a chain. So I don't think the local chains work very well. So we'll do 42. And then in here, you would put like, alchemy.io/blah, blah, right? So you can go to Alchemy, get a URL. I'm going to expose one as a .env variable. So if I do .env.local, I can add in here a next public RPC URL. And then in the front end here, I can do process.env.next public RPC URL. And this, so since I'm doing 42, this has to be a Coven RPC URL, but you get the picture. Now that we have a new Web3Modal, we can go ahead down here, async function connect, and we could do all the normal stuff like the if and the try catch, but I'm just going to do it like this. Const Web3Modal provider equals await Web3Modal.connect. Now this is going to be the same as like request Metamask accounts, etc. So I can do Web3Modal equals new Web3Modal cache provider. It's going to be false. Don't set this to true, otherwise you'll be really confused as to why it stopped showing up. But if you want to cache the provider, you can make that true. And then provider options, which is required, and what we put up here. And this needs to be wallet connect, not wall connect. Let's do a refresh on the front end. And if you run into some issues, you might want to go to inspect, application, storage, and clear site data. Because sometimes it'll cache the provider and you actually don't want that. So now we'll hit connect and we'll get this wonderful little modal, which will pop up. Let people choose how they want to connect. We'll use Metamask and boom, just the normal stuff. And great, now you can do your whole Ethers thing again, which I'm not going to show how to do. But once you connect, you can just do something like boom. Provider is this Web3Modal provider. Boom. All right. So we only have one more, and I'm just going to show you all real quick without actually going through it because it's real similar to what we've already been doing. So I'm not actually going to code this one, but this last one is going to be useDapp, which has another one of these bells and whistles. It's got all these React hooks. It has provider. It has context. You can check out the documentation here. And here's basically what we're doing. We're wrapping things with this DApp provider. And we have this multi-call thing. If you're unfamiliar with multi-call, go check out my video on multi-call. And same as Moralis and Web3-React, we have these hooks called useEthers, activate browser wallet, similar to activate or enable Web3. And then we have, similar to Moralis, we also have this thing called useContractFunction, where we can have this contract called store. We use this contract function and we get this function called send, which we scroll down, we do onClick send 42, and it works the exact same way as we've seen. Whew. So with that being said, we've gone through 6 different ways to connect your front ends to MetaMask or any other wallet. We've done it with pure HTML JavaScript. We've done it with pure NextJS and Ethers. Then we've moved on to Web3-React, which is used by protocols like Uniswap and Aave. And then we moved on to having even more hooks and more functionality and more feature richness using Moralis. Then we've been given the optionality of having this built-in plugin if we don't want to code all the different connectors ourselves of the Web3Modal. And then finally, we've also used useDapp as well, which is another great hooks alternative that you can use as well. So that is 6 ways to connect your applications. Thank you, and talk to you soon.
At 1K subs, we did VRF Pizza. At 10K subs, we did NFT Tattoo. At 100,000 subs, we're doing another 16-hour free code camp video. So the prize for us getting to 100K subs, you guys want to just be more educational content?
Man, I guess that works. But I'm already working on another 16-hour video. You're gonna get that. I swear I'm working on it. I swear. So let's look at second place. Christmas reveal at 100,000 subs. And also another 16-hour video.